So when you're doing iOS programming, you're going to be programming mostly in Objective-C. And what is Objective-C? It's an object-oriented extension to ANSI-C. So it's basically C with some object-oriented extensions added on. It's an old language. It was developed in the 80s based off of Smalltalk. One implication of the fact that Objective-C is an extension to C is that you can use C anywhere in your code. So you can use C without thinking twice about it within any of your methods. So when you look at Objective-C classes, you're going to see a lot of shared concepts, but there are some differences in how it communicates and how it behaves. One of the biggest visual differences you're going to see is that there are a lot of brackets. So you're going to see square brackets pretty much throughout the code instead of what you might be used to, sort of a dot parenthesis type of call for your methods. And the other thing you're going to see is Objective-C, especially Apple's frameworks, tend to be very verbose. So you're going to see method calls that read a lot like sentences. So let's look at what an Objective-C class is. Well, it's similar to, for example, C-struct or any sort of container or chunk of memory. It contains variables and it contains methods, which is not the same as all programming languages. Each Objective-C class consists of a header file, and the header file has a list of the variables, has a list of public methods that the class implements, and it has an implementation file, or a .m file. And that file contains actually the actions or the methods and all the programming behind it. So I said before, classes contain both instance variables and methods. Now classes can also contain static or class methods. So in other programming language you'd call it a static method. Objective-C calls it a class method. And basically what that means is that the method is operating on the class rather than on a specific instance of that class. So for example, you might call the class to give you back a new object, a new instance. That would be the simplest and most popular static or class method. And we're going to look at that in code very soon, so you'll get a chance to see that. Other things about Objective-C. It has a dynamic runtime. So the methods that get run can be decided at runtime. The other thing that you'll notice is that there are no namespaces. So you're not going to bring in a bunch of using namespaces at the top of your files because Apple only has one namespace. So a lot of times you'll see in code people use prefixes. So for my view controller, I might use my first two initials, DW, in front of it and say DW view controller. So it doesn't confuse it with someone else's view controller or with some framework method that Apple has implemented. So memory is managed, or actually can be managed. There's two options that you have here. One is manual memory management. And if you were programming for iOS 4.3 or lower, you'd probably want to use manual memory management. And in that case, what you do is you actually have to allocate instances of your class and release or destroy instances of your class to control the memory. Now Apple has this new method and it's called auto release counting, or abbreviated ARC. And what that does is it keeps track of when you create a class and when that class is no longer going to be used. And it automatically deallocates the class when you're done with it. And in most of the demo here, we're going to be using auto release counting, or ARC. So another feature of Objective-C that you'll see a lot is key value coding. And that's used a lot in inter-class communication. Next thing is flexible typing. So you'll be able to cast your variables, and you'll also be able to have an overall type that encompasses all Objective-C classes. Another thing that's unique to Objective-C is calls to the instance of a class are called self. And this is similar to, in Java, you would say this. One more thing before we get to the demo is inheritance. So just like a lot of programming languages, one class can inherit or be a descendant of another class. So the subclass, or the child class, will automatically inherit all of its parent class's methods and all of its variables. And the easy way to override any of this parent class's methods is you just redefine the method in your code and it will override that method. And the other important thing to know is that all Objective-C classes will inherit from NSObject. So that's the base class on which everything else is designed. And the type ID is the same as NSObject. So you'll see things called ID in the code, and that just means it's some type of NSObject. So let's actually look at the code and build ourselves a class. Okay, so let's create ourselves a class. I'm going to open Xcode, make a new project. Single view application. I'm just going to call it sample classes. And this time I'll use storyboards. Save it to the desktop. Okay, and let's dive right in and make ourselves a new class. So I'm going to go to File, New. Make a new file. And here we get to choose a template for our new file. We're going to go to Cocoa Touch. And we're going to choose Objective-C class. Go to Next, and you can see our namespace here is AD, that stands for App Dev. And I'm going to call the class my class because I'm not very unique. Click Next and create the class. And here it created it in the folder structure. I'm just going to put it inside this folder. Keep things organized. And let's look at the header file of the class to start with. So as you can tell, there's no namespace. There is an import method here. So what this is doing is it's importing the foundation framework. And you need two frameworks in Objective-C classes to start with, especially if you're using UIKit. You need the foundation class, and then you need the UIKit Cocoa class. Now if we go into supporting files here, and we look at our our prefix file, you'll see that Xcode is automatically going to import UIKit and Foundation whenever it sees an Objective-C file. So let's go back to my class and look at that header. So it's importing that anyway. Now let's look interface. This is in our header file, and what our interface defines is our variables, our instance variables, and it defines our methods. So that's saying that we're going to be defining that information. AD my class, that is the name of the class that I created. So AD my class, AD my class. And then the colon just says that this is a subclass of NSObject. So in other words, we're creating a class that's just at the root structure of the class hierarchy here. Now if we want to add instance variables, we use these curly brackets. And we can add an instance variable. And remember I said that you can use C, so you could just type in int here. We'll call this my value. So I declared an int called my value. Could use other variable names. And then you can also use Objective-C variable names. So instead of a character string like you might use in C or some other string, Objective-C uses NS string. So we'll make an NS string class and we'll call it some string. So there we named our variables. Now we can also name methods here. I'm going to make a method to print to the log our value and the string. So this little hyphen here means that this is an instance method versus a class method. Class methods get pluses. So do the minus void, so the class returns a void when it's done, or the method returns a void when it's done implementing. So you type in, so after your method is finished, it just returns nothing. And I'm going to call this print something to log. And then I end it with a semicolon. And then when I'm done with the interface, I need an @end here. So the interface starts with a @interface, and it ends with an @end. This little @ sign should tell you that this is an Objective-C hint to the compiler, I guess. So you'll notice that my class here starts with a capital letter. And that's an Objective-C standard. So any class should start with a capital letter. If you look at Apple's classes here, you'll see all the ones that they've added use capital letters. And then instance variables always start with lowercase letters. So when you're looking at anyone's code, any code that I've ever seen, you'll always note that both the instance variables and the methods are lowercase and the class name is uppercase. Okay, so let's look at the implementation file, and I'll copy that method in. So in the implementation file, the first thing you'll see is that it's importing the header file for the class. So ADMI class header file, it imports the header file. So that's how it knows about our instance variables. And that's how the compiler can check that we've implemented all the methods that we defined up here. Okay, so let's print something to the log. And I'm going to start using a new view here because it's very handy when you're looking at header and implementation files. So I'm going to click this bow tie view, which is called the Assistant Editor. I'm going to get rid of our side views here. I'm going to change this to the header file. So now you can see the header files right here and the implementation files right here. And that's handy because you can see what your variables are. And you can see which methods you're using. So print something. In Objective-C, sending something to log starts with NS. And incidentally, everything starts, or a lot of things start with NS. That stands for next step, and that's the framework that was in place before Apple started using Objective-C. So we'll do an NSLog statement. And I'm going to go through this step by step, but first I'm going to type it all out. Okay, so that's the log statement. Let's look at what it means. Okay, so first the @ sign. This is making this into an NS string. And then it just prints out this value. The $D says to print the integer, my value, which is over here, belongs to $@ tells us to print the NS string, which is some string over here. So when this prints out, it'll print out this value, whatever it is, belongs to some string. So this value goes from left to right, so you get $D picks up my value, and $@ sign picks up some string.